The following is a demonstration and a test run on a 2 combined dual stack of MOTs, which stands for Microwave Oven Transformers, or MOTs for short. They're all enclosed in this case, which I'll point to right now. And that's a total of 4 MOTs inside this stainless steel deep fryer case, approximately this position. 1, 2, 3, 4. With a modified shredder lid, Bakelite high voltage terminals on the far ends there. A series of high voltage stickers on the top, on the sides, and also indicating where the high voltage terminals are as a warning, because it's a very high powered unit and as a result could be very dangerous. There are the two dual stack MOT units operate as one, you see, to give you a 10,000 volt 5000 VA transformer, and this can be built at home, lab, or a workshop for a fraction of the cost of an equivalent transformer. Here we have a nice metallic strip connected to one of the terminals for demonstration purposes. The other end is connected to a free, well-insulated cable with a handle. It's over here, and inside that plastic is the handle. Behind is a 4NF homemade high-voltage polypropylene condenser. It's not entirely necessary except for the purpose of this demonstration. It's simply connected across the terminals. An orange wire and red wire. High voltage support stands, including a couple on the lid for the high voltage meter, which reads up to 10,000 volts, full scale deflection, with the support stands and insulators. Okay, the cable, there's a high voltage meter is there, and high voltage cable that reads the meter running here. A current meter on the 240 volt side, the current meter. Adjustable homemade current limiter controls our 240 volt currents from 25 amps. The core can be moved in and out to adjust the current. We also have a neon transformer of a similar voltage for comparison, just over here. But our unit has up to about 5 to 10 times the power output of this particular unit. Okay, so first let me explain what I mean by a MOT dual stack. And then we'll do the demonstration. Shown here in this video is a smaller 600 watt microwave oven transformer, so that you can see what it looks like. This one has a high voltage connection that's connected to the ground because it's also used as a current limiting device, like this, but it's not adjustable. This one would limit the current up to about 15 to 20 amps, because that's the current you'll draw when it's shorting out. Okay, and in combination with a additional transformer unit, it then acts as a current limiter in series with the circuit. This one's from an older unit, that's why it's a lot bigger. They make them a lot smaller. They probably stopped making them now because emphasis is focused on efficiency, or efficiency ratings in power units and microwaves. These ones used to draw heavier currents. And of course, as they started reducing these iron the amount of iron that they used in manufacturing these, they became smaller and smaller and were drawing on their own more and more current. So long as during operation they did what they were meant to do, that's all that mattered. Right, so firstly, before we describe what a stacked unit is, MOT, as mentioned before, stands for microwave oven transformer. Here's a drawing of one, just like the one that we just showed you. This is these have been tested, or the ones I had here have been tested between 600 to 1500 watts. The voltage on the high voltage terminal ranged from 2200 all the way to 2900 volts. Their unloaded current, they drew 2.5 to 5 amps. There's a 6-volt winding in here, tucked in there, but we're not interested in that, so it's not necessary for this presentation. There are metal sections or shunts inside there. We can leave those alone because unless you're planning to dismantle them, they're probably best left alone. There's a 240 volt winding just here, and here's a circuit diagram of what we're talking about. The 240 volt winding sits around in the lower end of the core. It's balanced so that the active is on one side, neutral on the other, and produce a higher voltage on one and a lower voltage on the other terminal. The other terminal is actually connected to the core on the opposite side via a pin. Once it's grounded, all the high voltages on the main terminal. Now, as we've said, loaded, that's when you're shorted. These units ranged from 10 to 25 amps. So at 240 volts, that's 2,400 watts all the way up to 6,000 watts, which is an approximation only of course, the total loaded VA rating. Now, and at 2,200 volt, the smallest ones could deliver up to 1 amp, and the largest up to 2 amps, and that's dangerous. Hence, I've put a little danger and a warning, and hence the danger stickers, because these units can kill. Make no mistake. Only 30 milliamps, which is 0.03 amps, can cause ventricular fibrillation. A sustained shock of only 120 volts at 50 to 60 hertz can do the same, or a current as low as 30 microamps passing directly through the heart. Okay? Less than 200 volts, the skin can cause impedance, which could protect you, but at 400 to 600 volts, there's a dielectric breakdown of the skin occurs and you've got very little protection. And hence I would like to have a disclaimer at this point. These currents are extremely lethal and are to be taken seriously and respected. I hereby am not responsible and claim no responsibility for any mistreatment of these units or irresponsible practices. This video shows a number of dangerous practices involving potentially lethal currents at high voltages. Also, these experiments operate from 240 volt AC main supply stepped up to far higher voltages at high currents, which can easily cause death or great injury. Do not build unless you know exactly what you are doing. Do not touch any part of the equipment while it is plugged in to the mains 240 volt outlet. If connecting a condenser, as I've done, or any kind to the equipment, do not touch any part of the equipment. Even when the equipment is not plugged in or switched off, high voltage condensers can kill unless they are discharged safely. Please remember that the methods described may not conform to any electrical safety standard, and many experiments performed here, like this one, is downright dangerous. Neither do I endorse the methods that I use to demonstrate this energy shown. The experiments were done also, and these ones, done under carefully planned conditions and circumstances, and I will not be liable for any consequential, incidental, special, indirect or exemplary damages to persons or property, be careful. Use good solid judgment in your work and think and plan ahead. Safety is your responsibility. The following rare footage from our archives shows the 1991 Q High Voltage Laboratory. And here, introducing our first microwave oven powered Tesla coil, perhaps even the world's first, operating off just one single MOT.
What's the wattage of it?
Oh, I'll tell you in a minute.